सर आले.
Good morning, all students. Write your name.
Good morning, sir.
Good
morning, sir.
Good
Good
morning,
morning,
sir.
Good morning, sir.
Good morning.
फिजिक्स आत्ताच संपून आले सगळे ना.
Oh,
Oh, sir.
Write your name and your roll number in the chat box and mute yourself. The screen is visible.
Yes, sir.
Yes.
yes, sir.
Yes.
Okay. 59 students are joined. We will wait for 1 more minute and we will start.
Yes, sir. Okay.
60.
Okay, sir.
Yesterday, many students are absent. For these students, those who are absent yesterday, I want to tell one thing for these students. Yesterday, we started the new chapter, hydrocarbons. It is having the weightage of 11 marks with option and without option for 8 marks. Means your total paper is 98 marks. So out of 98 marks, this chapter will get 11 marks question. Out of that 98 marks, we have to solve 70 marks of paper. So out of 70, it will contribute 8 marks, and out of 98, it will contribute 11 marks. Means if you prepare this chapter very well, you will get 11 marks, remember, with option. So the introduction part is already completed. What is mean by hydrocarbons? Then we also discuss about the alkanes. So once again, I will conduct a quick revision. Alkanes, actually, these are paraffins. कुणाचा तरी माईक सुरू आहे बरं का. एक सापडला आविष्कार माळी. So paraffins, actually this is a Greek word. Paraffins means which is having very less reactivity or very less affinity. Affinity means reactivity. So chemically, actually, the alkanes are less reactive in nature, but in some certain conditions they can undergo various reactions. We will discuss in next part. So what is alkanes? Alkanes, these are the aliphatic saturated hydrocarbons. Saturated means single bond wale. They having the carbon-carbon single bond and carbon-hydrogen single bond, having the general formula CnH2n plus 2. This is the general formula of alkanes. This also you learn about these alkanes in 10th standard. The first member is methane, then ethane, propane, butane, up to C20. Also I explained in this chapter basic principles in chemistry. Isomerism part also we discussed, these examples also we discussed yesterday. So go through the notes provided to you. Today we will start, this is a new point, conformations in alkanes. So conformations means what? I will explain first. Conformation means, see the definition is given in italic form. The different spatial arrangements of atoms in a molecule. In a molecule, there is a different arrangement of atoms that can be converted into one another by free rotation about the single bonds. It is called as conformation. Means, as per the definition, we have to take into consideration, means in a molecule, there is a different arrangement of atoms. It is called as conformation. In simple words, conformations can be defined as the molecule is single, but the arrangement of atoms is different. It is called as conformation. It is also called as conformers or rotamers. Also note down these different words. These words can be used for the examination point of view. And student only focus on the conformation. They do not focus on these conformers or rotamers. Also note these words. So these isomers cannot be usually isolated because they interconvert rapidly. Means I will explain here. See, in these examples, these are the conformations of ethane here. CH3, CH3. This is a one CH3. This is another CH3. This is a Sawhorse projection. In the chapter number 13, in that title, representation of organic molecules, we discuss about this Sawhorse projection. In case of Sawhorse projection, this carbon-carbon bond is slightly elongated like this. See, so this is eclipse form. What is meant by eclipse? I will explain. See, in case of eclipse form, all the hydrogens, see, means the direction of hydrogens is same. See, this is a first carbon and this is the last carbon. This is first carbon, this is the last carbon, and see the positions of hydrogens. Positions of hydrogen is same. When such type of situation is there, it is called as eclipsed. Means the direction of hydrogen is same of both the carbons. But see this staggered conformation. In case of staggered conformation, see this direction of this hydrogen which is attached to the front carbon, and see the direction of the hydrogens attached to the backside carbon. So if it is rotated like this, we will get the eclipse can be converted into staggered. So these are the conformations of ethane molecule. Ethane molecule. So as according to the definition, conformations are the molecule is same. This is also ethane. This is also ethane. The molecule is same, but there is a spatial arrangement of atoms. See, the position of hydrogens is changed. So we cannot isolate this eclipse separately. We cannot isolate this staggered separately, because immediately the eclipse can be converted into staggered and staggered can be converted into eclipse. So the line is written here. The isomers cannot be usually isolated because they interconvert rapidly. Immediately this process. Now the screen is visible.
Yes, sir.
Yes, sir.
Yes, sir.
There is a little bit issue of the internet connection. That's why we getting difficulties. Okay. So,
sir.
so this is a conformations. Remember, conformations means, I think you understand. So in this Sawhorse projection, there are, this is explained. This is a Sawhorse projection, and this is the right hand side. We can see this is a Newman projection. In case of Newman projection, the front carbon, it is denoted with a single dot, and the back carbon is denoted with the circle. So hydrogen attached to the back carbon, it is denoted with these blue lines. See, the bond between carbon and hydrogen, it is denoted with blue lines. Blue lines means these hydrogens are attached to the back carbon. This circle indicates the like this.
सर आवाज नाही येते.
आवाज येत नाहीये. एक मिनिट.
आवाज कट होतोय.
सर मध्ये लॅगिंग होतंय.
इंटरनेट कनेक्शन थोडस आपल्याला. आता येतोय का आवाज बरोबर?
हो सर.
हा येते सर.
ठीक. Okay, I will continue. So in the Newman projection, we can see there are two carbons. The front carbon is denoted with single dot, and the back carbon is denoted with this circle. We can clearly see the circles. So the hydrogen attached to the front carbon, it is denoted with black lines. We can see the three hydrogens are there, and hydrogen attached to the Backside carbon, it is denoted with blue lines. See, this is a first hydrogen, this is second hydrogen, and this is third hydrogen. So in case of eclipse Newman projection, all the hydrogens are nearer to each other. But if it is rotated, we can see here angle of rotation. See, if it is rotated means, see, the back carbon, it is shifted to right hand side. If it is shifted to right hand side or left hand side, we get, this is staggered conformation. So staggered conformation means these hydrogens are away from each other. This is a stable conformation. An eclipse conformation is not stable because the hydrogens are closer. So there is a steric hindrance between the two hydrogens. So this is a less stable conformation and this is a stable conformation. Staggered conformation is very stable. And how this is converted eclipse into staggered? By rotation of carbon-carbon single bond. Clearly we can see the back carbon is rotated to right hand side. So it will be converted into this staggered conformation. So it can be asked for the 2 marks for the examination. Write the eclipse and staggered conformation structures of ethane molecule in Newman projection. They can ask Newman projection or they can ask Sohars projection. So make a practice at your home. The next part is methods of preparation of alkanes. How alkanes are prepared? First method is industrial source. This is deleted for